So today will be a hardly to learning day, and so we start from our daily routine. Sorry. Okay, so please turn on your cameras. We can make a photos with you, and yeah, perfect. Sunday morning, or Sunday afternoon. Yeah, but you not sleep, guys. You feel awake. You look very energy. Okay, so anybody turn on cameras? Okay, make the first photo and we smile, of course. Three. Oh, hi, quiet. 3, 2, 1. Smile. Hey, great. Just a moment. Okay, so Bruna, mount your camera, please. Okay, and let's try again. And photos with smiles. And 3, 2, 1. Smile. Hey, perfect. And the last one, photo. Are you ready? Where is your smile, guys? Where is your smile? Hey, hi, Elena. Yeah, I see your smiles. And 3, 2, 1, smile. Perfect. Yeah, great. Amazing Sunday day. Okay, so I think we can start. And today, Timofey will tell you more interesting features of Gazebo simulation. And after it, to finalize our meeting, I will tell you some interesting facts about how you can improve your skill and what event you can participate and some words about educational trajectory, especially for you. Okay, so I think we can start our training. And Timofey, you're welcome.
Yes, hello again. Let me start my screen sharing, and I will begin with, let's see.
Yeah, and don't forget to ask the questions during the webinar in the Zoom chat. But when training will finish, you can ask us into the Telegram group, COEX support.
Okay.
It will be effective. Yeah. Okay, let's go. Let's fly.
Yes. So one thing I want to tell you about is the service called Telemetry. This service can give you the data from your drone, mostly from the flight controller, like what coordinates you have right now, what is your drone's rotation in certain frame ID, and also the mode that the drone is now is. So like can be in stabilized or in offboard and so on. And I will tell you why do you even need to use this service, because I think this is the second most popular service in Clover after Navigate. You can really use it a lot in your programs. And in Flip, it is also used. So some of you who have done their homework, you saw the use of Get Telemetry. And if you don't understand how it's working, I will tell you about that. So let me go to the simulator and show you how to access this service. Well, all the services can be accessed either from your Python script or from a terminal, from any other script if you use ROS. So in ROS, they're always available. And basically what services are, service is a function that is performed on another node. So if this program is a node called flight, you connect this node to ROS, of course, by importing ROSPy and initializing this node. And you get all this service proxy, get telemetry, navigate. Whenever you call this service, like navigate, ROS will send the command of the service with its arguments to the node that is performing the service. For example, if you call navigate, another node is activated and uses these parameters to actually navigate the drone. You do the same thing with get telemetry. But first, before I show you this in code, I better show this in the drone. In the command line, it will be easier for you to understand how it works and what does it return. By the way, is there anyone who haven't installed Gazebo yet? Like, I know many of you already have installed, but some of you might not. Okay, and did you have any problems, or you just didn't have enough time for that? So the simulator is here and running. Okay, great to hear that you have resolved the challenges. All right, first thing I will do is I will take off the drone the easiest way with commander take off, and on the other terminal I will call the service called telemetry. To call the service, I type ROS service call /get tab, and now I have get telemetry here. I press tab again, and here it says frame ID equals. So here in frame ID, I need to provide a frame that I want to get telemetry in. If I leave it blank, it will give me the frame ID map, the default frame ID for all the services that contain frame ID argument. So if I do that, it will return me the parameters, the X, Y, and Z in map, and also the Vx, which is velocity by x-axis, Vy, Vz, and pitch, roll, yaw, and pitch rate, which is the angular speed of the drone in radians per second. Also, you get voltage and cell voltage. This is available on a real drone, and here sometimes, well, for now this is not available, but usually it is. So there will be a simulated voltage. So if I go to another point, let me do this by calling a service navigate. So ROS service call /navigate. I showed you that yesterday. Tab. And let's use frame ID argument. 1 meter per second. Z2, Y4, X4. Let's go. And now it says the copter is not in off-board mode. So I didn't use auto arm. And let's see what the previous response was from the get telemetry service. The mode was auto takeoff. So this is not the off-board mode that Navigate is working in. So when you use Navigate without auto arm false, it requires that the drone is already in off-board mode. If you put auto arm equals true, the mode will change to off-board during this Navigate. So I need to copy the previous comment and replace false with true. And now the drone will fly. And now whenever we get the telemetry, but using the frame ID argument, it will give us the coordinates of the drone, the speed of the drone, and many other parameters. For example, you now have voltage and cell voltage, but this doesn't really make sense for the simulation. And XYZ is 3.8, 3.8, 2.06. It's almost on top of the marker. I think if we run telemetry again, the values will be more precise. Yeah, this is now 4.4, much more precise. Okay. Telemetry can also give you the speed of the drone. So if I have a Navigate with the coordinates, let's say the speed will be 5 meters per second and the coordinates will be 9 and 9. And then I will quickly call get telemetry. Get telemetry. You now see that Vx and Vy changed, and this is exactly what we wanted to see. So 2.5 and 2.5 on x-axis and y-axis, and the coordinates from the time that I called get telemetry were 6 and 6 meters. So this is a nice way to get data that tells you where the drone is and what is its other parameters. Why do we even need to use that? For example, if I want to return to the position where the drone is currently located, so this is the drone and it's located in this position. I want to perform some action and make the drone go back here. I can get telemetry in my code, store it in a variable. Then I will perform some actions and will go back to the same position that was during the time that I get the telemetry. And this is how Flip is working. Together with you, we will go through the Flip code. It's in code snippets. Let's wait for the code snippets to load, and we will make this flip work. You can have access to GPS if you, on a real drone, you need to enable GPS, and you can use it. In the simulator, you can also simulate GPS if you need that. So you need to find settings and Clover Launch. Okay, the code snippets here. I will stop the simulator for now because I don't need it to be working. And let's find the flip. So here's our piece of code that you tried, and some of you faced the problem that the drone is falling on the floor. We can edit this and fix the problem. I will open the Visual Studio Code, create a new file, flip.py. Control V, and this code is missing something. So here you need to provide all the services proxy and ROSPy init node. So this is what we can copy from here. Let's do that. I copied this from my previous program. So there is a math module that is used to get the pi value. And let's call the node flip instead. So those are get telemetry and navigate services. And we also have land. But this doesn't land actually, so this program will stay in the flight. We can add land later. Some other services are also used, like set rates. This is the service that I will tell you about when I overview this function. Okay, so first thing is the pi2 variable. This is actually the half of the pi. You will use it in your code. And then the function flip is defined. Def flip. This function doesn't accept any arguments, so you basically it always does the same flip. You can actually set some arguments if you need, but it's not required here. So first, what I told you about is get telemetry, and start is the variable where we will store the data from telemetry. So start equals get telemetry with empty parentheses. Why is this empty? Do you remember what frame ID is used when we have empty parentheses, or frame ID is set? Well, we do not provide any frame ID. There is also always a default frame ID that is used, but this is not Aruco map. This is another one. If you remember, you can write in the chat. Well, if you don't remember, I'll just tell you that this is the frame ID map, and so we get telemetry in map. Why don't we use ArucoMap here? Because this flip is designed to work even without ArucoMap installed. So if you have just a bare field without any Aruco markers, the drone also can fly in these environments. And you will be able to have a flip in this environment without Aruco Map. So you will use map instead, and the flip will just work fine. So before you call flip, you need to take off to a certain height. And here we have, like here, print navigate. Well, basically, print navigate is the same thing as navigate, but it also prints you some information about this navigate. And as you can see, there is no parentheses after print because this is the Python 2. The Python 2 does not require parentheses after print, so print is not a function; it's a keyword. Okay, so you go up to 1 meter with a speed of 1 meter per second. And after 10 seconds, this is too much in my opinion, I will change it to less than 10. Then you flip. So Rushby login for flip is just for logging, like printing that you are flipping, and then you flip. Okay, so the function itself contains start equals get telemetry. So you, in the place where you took off, you get telemetry in this place, and after flip, you will try to go to this place, back to this place. Okay, then you have set rates and so on. Before we continue, I will save this code and test it so you can see the problem that we face during this flip. I will change this to 5 seconds, or yeah, let's have 4 seconds and the Z 3 meters. 5 seconds, okay, like that. I will run Gazebo PX4. If I hold shift, I can rotate the camera. Okay, and let's run our code from Visual Studio Code. Click this green play button. Did it work? Yes, now it will start the program in this console.
Oh, Timofey,
Yeah.
while we waiting when code is loading, so could you answer the question from Bruno about GPS antenna and getting access to GPS coordinates in Gazebo?
I already answered the question, actually. So the drone is now taking off, and now it's going right into the ground. So the flip didn't work, and the drone is losing its mind. This is not what we expected to have. And there is a reason for that. I will stop the simulation and let's fix our flip. In order to fix the flip, we need to understand how it works. So this line is already, I already described how it works. You get telemetry and that you will later use to go back to. Then you have a service called set rates. If you forget what set rates is, you can go to simple of board article and read about this service. All right. So set rates is set pitch, roll, and yaw rates, and the throttle level. This is the lowest drone control level. So this is basically what you use to set pitch, yaw, and roll of the drone, including thrust. So we didn't use pitch rate, roll rate, yaw rate, and auto or argument of set rates. We only used thrust. So thrust is how much thrust we have. If it's 1, it means that this is the maximum value. It goes from 0 to 1, and if you have 0, it's 0 thrust. If you have 0.2, it's like 20%. If you have 1, then this is 100% thrust. Then we sleep for 1/5 of the second. Then we have set rates again with pitch rate of 30 and thrust of 0.2. Pitch rate is the speed of rotation, how fast the drone is trying to rotate along the y-axis of the drone. So pitch, if you have your nose up or down, the axis you go around is y. So x is facing forward, z is going up, and y is going left. So you rotate it that way. And it is trying to rotate with the 30 radians per second. Of course, it will not reach that speed in just so small amount of time, but it will try to. And the thrust is also an important value here because it says how much energy, how much power on the motors you have. So in this situation, you need to change thrust to like 0.4, and that should be already okay. So that should work now. I don't remember the exact values that we used to have it working, but I can check them later. So after we set these rates, we go into an infinite loop while true. And that's the following thing. First, it gets telemetry again stores in the telem variable. Then you calculate the flipped variable. What is flipped? This is the variable that will become either true or false, depending on this expression. It measures telem.pitch. So what is your pitch? And it compares this to the half of pi. So if you pitch more than 90 degrees, it will become more than half of pi, because 1 pi is 180 degrees, 2 pi is 360 degrees. So half of pi is 90 degrees, and flipped becomes true if either telem pitch becomes more than half of pi, or telem roll becomes more than half of pi. Why even is there a roll? Because you can either flip along pitch axis or along roll axis. So if you uncomment this line and comment this one, you can have a flip not that way, but that way instead. Okay, and then if flipped is true, so if just flipped, so this is the same as if flipped equals true. So this is the same because flipped is already either true or false. If flipped, then break. So this loop breaks whenever you reach this half of the pi. And then there is log info, which is nothing to do with the program logic, just a logging. And then you have set position, another useful service that's available for you. It's like navigate, but it works a little bit differently. It doesn't have speed argument at all. So in set position, there is no speed. The speed is always maximum. So the drone will try to go to set position as fast as possible. So set position, and x equals start.x, which is what? Which is the variable that stores initial telemetry. You can do it that way. Set position is equals x equals start x, y start y, z start z, and yaw start yaw. So you will also go. You also have direction of your drone the same as in here. So this is the flip function. This is it. You can also change the value, the pi over 2 value. You can have like pi over less than 2 to make the drone rotate a little bit more with higher thrust before it starts to stop its own rotation. But let's try it with this configuration now. Let's play. So now you saw that flip was performed fine. So this change was enough for the drone to perform the flip, and you can do it in your own simulator if you have. Like if you have installed this and used the script already, and you will be able to complete the homework fine. For now, do you have any questions about flip function? Okay. Okay, the next thing I wanted to show you was the laser rangefinder. So laser rangefinder is actually a sensor that is located under the drone and it's pointing down. It measures the height of the drone. Well, actually not the height of the drone, but the distance between the drone and the nearest obstacle. It can be ground or it can be a box like what we have here. Using this information can be useful for solving different tasks. And the rangefinder data is always posted to a topic. And this is what I'm going to show you right now. You already saw some topics that were image topics, and you accessed them in browser, like going to localhost 8080. So this is the list of image topics. But there is a plenty more topics available in rows in Clover, and you can find the list of the topics by typing rows topic list. Okay, look how many topics there is. First, there are some topics that are only specific to the simulation, like Gazebo, link states, model, and so on. So these topics will not be available on a real Clover, and you don't really need them. But there are some Aruco map topics, main camera topics, like main camera image raw. This is what you see here, and all the other topics. And there are Mavros topics. Mavros is Mavlink plus ROS. So a ROS module that connects ROS with Mavros. And many interesting topics are in Mavros. So if you look for the information from Mavros IMU data, you will see the real-time data from your flight controller, from IMU basically, from your sensors. And let me show you that. To listen to the topic, you can echo this in console by ROS topic echo slash Mavros slash IMU slash, what was that? Data. And you can see a lot of new messages appear here. I will stop listening to this topic because it will clutter all the console here. So this is the data that is stored in this topic. So it starts here from header, seq, which this means how many messages already here? 3,930 messages already. So this is the message with the number 3,913. Okay. Then some time and frame ID based link. So basically this is another frame ID that is connected the hard way to the drone. So whenever you rotate the drone, the axis will follow, the axis of base link will follow the drone rotation. And you will get the angular velocity here and linear acceleration and some other information. So angular velocity is how fast the drone is rotating. The linear acceleration is basically the acceleration of the drone. But look, there is a fun thing about acceleration that not everyone understand from the first time. So if you have now x acceleration 0, y acceleration is 0, and z acceleration is 9.83, and so on, what does it mean? Well, basically it means that the drone is experiencing acceleration right now. But from the physics lesson, you probably learned that a static body that is not moving, it is not experiencing acceleration. Well, it actually is experiencing acceleration, which is g-force, and g-force is always pointing to the ground. And if you rotate the drone, if you flip the drone, for example, the acceleration will change here, even when the drone is standing still without moving. The acceleration will flip if you have if you will flip the drone. If you put the drone like on its front, you will see the acceleration in the x-axis and not in the x. So here instead of here. This is a fun fact. You can access this data from your program and use it if you need to measure the drone's acceleration, the force that is the drone is experiencing for some reasons. It may be used for detecting collisions and some other interesting programs. Well, this is basically how you get information from a topic in the console. But you can also get information from the topic in program. And we are going to get information from our rangefinder. And let's first topic echo/rangefinder. I press tab several times. Yeah, and it completes this message. Enter. And you will see, wait. This way. Okay, you will now see the data from rangefinder. Yeah, here it is. It has some header information and some other information, and in the end you get the range piece of data, which is the distance measured by rangefinder. It's almost 0 here, but if we take off the drone, it will not take off because of some internal errors occurred. I will need to restart the drone to take off. Whenever I stop the simulation, there will be no new messages in here. But when I start it again, they will appear. Let's see. So now we continue to receive the messages from rangefinder, and they're still about 0. And we can take off now. We can when the window is loaded. Yes, now it is loaded. So it is taking off. And let's see how the values will change. 0, still 0. And now the value is growing. It's almost 40, 50, 60, 1 meter, 2 meters, 2.3 meters already, 3 meters and 30 centimeters. So it's more than 3 meters already. This is the range that you get from rangefinder. And now it is going down to some distance. Let's see where it is going. Okay, it's now in 2.3 meters high. But when we fly above this tower or this tower, the value will change. So in order to fly to this position, we can find our previous program. When we hit these towers, and we can edit the values from there. Navigate Spy Sleep and navigate to let's find where is an obstacle. Oh, let me better put another obstacle to the place where we are already heading to. So it's 0 and 5 by y-axis. So here I will need to place a cube. So I click here and drag just click here again to get the cube on the Steam. Let's run this code. You know that the drone is not standing on the ground, but that code will be performed anyway, because what it does is take off to 1.5 meters from wherever it is now. So it was already at some height. It will take off even higher, then go back down. And now it's flying very quickly to this point. And let's see the data from the rangefinder. It is now going to be, here you can see 0.5 meter, 0.5 meters. The drone is flying above this box. Let's see if it even detects any markers. No, it doesn't detect any markers, but still able to fly above the box. Oh, it just landed on the box. Okay, it wasn't a good idea to fly so close above this box, because the drone has landed. We can take it off again, but you saw that you can measure the distance. You can measure the distance using this laser rangefinder. And one thing I want to show you is, if you have a stock, if you just downloaded this virtual machine, this particular version of virtual machine, and haven't installed the files that I've provided to you, the WSUni folder. So there is a fixed params file that you need to load to QRun control. Why do you even need to do that? Because on the default configuration of this version of simulator, it's not the same in different versions, but in this it is. By default, when you fly above obstacles, the drone uses data from a rangefinder and thinks that this is the Earth and the Earth is flat. Well, the ground is flat, of course, not the Earth. Um, and the drone will bump up when on top of some objects. To fix that, there is a parameter fix, and you need to keep Gazebo open during that operation, then launch key ground control. Ground control is the program to program the flight controller to change its settings and calibrate and something like that. Whenever it starts, it will connect to the clover automatically. Yes, and you can see that it is connected, and you can see the gauges here are a little bit imperfect. Okay, so let's go to settings, parameters, and go to tools, load from file, and now on my desktop, so on my desktop there is a folder VS-Uni and fixed params that I can click open, and I will need to restart the simulation now because otherwise they're not applied. Some of the parameters require restart. So let's restart the simulation. In your case, it might help if you haven't done it before. In my case, it won't change anything because I have already done that. Yes, and right now I will not run the Gazebo PX4 again. What I'm going to do is to write the program to measure distance by rangefinder. So I will just copy this program, rename it, and I'll open the article about our laser rangefinder. Here in the programming menu, you can find laser rangefinder, or that. Yes, interfacing with a laser rangefinder. This article will tell you how to work with, how to subscribe a topic, and how to get data from laser rangefinder. You don't need to configure any of that because it is already configured in the simulator and it is already enabled and the settings are already configured. And you need to find this piece of the article, receiving data in Python. So in order to receive data, you need to create a subscriber. Okay, and this is the code. Basically, you can just copy the entire code and run it. It will only give you the data from rangefinder, nothing more. It will not fly, but it is already a working piece of code. But I will not do that. I will use parts of this code to implement in my code. First thing is you need to import from sensor MSG SMSG import range. So you need to import the type of message, the range type of message. Init node is already in my program, but I have no def range callback in my program, so I need to copy that. Put it under the proxies.services. Okay. Then we have a subscriber and the ROSPICE pin. I need subscriber here, but I don't need ROSPICE pin because ROSPICE pin will block all the code below. So ROSPICE pin is basically an infinite slip. So you don't need to use that in your program if you don't want for the program to keep working without doing anything. So, but ROSPICE pin is in this program because otherwise the code would go through this lines and stop the program here without waiting for any time. And now, as we have ROSPICE pin here, the code will wait for the messages to appear. The messages will appear because we have a subscriber, and subscriber is basically working in some other node on the rows, and it will give you a new message. And every time you get a message, this function is called. So this is a callback function that is called every time a new message in topic appears. All right, I copy this subscriber and put it here. Okay, and now, since this moment, the program will always print some data. And what data will it print? It will print rangefinder distance is this MSG range. So let's test that. But before we test that, I need to change the speed of this flight because it is 10 meters per second. The coordinates are I think this should be 1.5 and this should be 2 meters and this should be 2 and this 2. Okay, Control S, and now let's run the code. So there is a question: what happens if I use different Aruko markers or in different order? Well, you need in order for the markers to work properly, you need to have the same setup in your physical markers location and your marker map that is stored in the drone's memory in the file in a TXT file. If they are different, then some problems may occur. For example, the drone may start shaking from one side to the other because it is confused where it is located. Because each marker tells you the drone's approximate position. And when you have two different positions at the same time, the drone might go from one to the other and just fall down once. So you need to have the same markers, of course, in order to work properly. Okay, I have my program. I can run this program. And we will see the output of that in the console. So you can already see the distances. Rangefinder distance, it's 0, 0, 0. When it starts taking off, you will see the difference. And when it reaches the obstacle, you will also see the difference. Okay, it is growing. The height will be 2 meters. And now the drone is coming here on top of this tower, and we will see the change. Now we see that this is 0.7, 0.75. I think there is also land on the end, in the end of the program, and it will land on the tower. So the program worked fine. So we basically can have access to any data from any topic in any program. And I showed you how many different topics are available. A lot of them. One more thing for you is don't try to open image topics from the console. It will you will be surprised by the amount of random numbers and random lines of text uh, that will be output here, and you can even hang the computer so it will not be responding. So don't try uh, to echo the topic with image. A lot of data. You have clock, so you can roast topic echo slash clock. And this is a roast time seconds and nanoseconds. And of course, these seconds are not the same as the seconds from that clock. And the fun thing is, look at this sim time 52, and this is 52. So this is basically the timer, the same timer. 53 now. And it's so slow because the real time factor is so slow as well. Okay, now Control C. Okay, do you have any questions on the topics and services? Okay. Okay, if you have no... Oh, does the change made in simulator affect the flipping in real drone? In real drone, well, flipping in simulator will be performed differently than in a real drone. So, for example, if you try to use these parameters on a real drone, the real drone might fall instead of doing a great flip. So I don't recommend you just blindly copy and paste flip from simulator to a real drone. For the real drone, the default configuration of the flip was tested and worked fine. If you use the 3S battery, like with 3 cells battery, and the PID settings from the settings article on our knowledge base. So if you basically just assemble drone and set the drone the way that is supposed to be, and use 3S battery, then the flip will work fine on a real drone. Otherwise, it might crash. Okay. So there is another thing that you can play with, which is fun, and is more fun on a real drone than on a simulated because it is much more visible. I'm talking about the LED strip. This is the LED strip that is available for programming. So you can basically control the effects of the strip and the intensity of it from your code or from console. So there should be a service called set LED effect. So our service call LED effect LED set effect spacebar tab. So this is basically an easy interface for controlling LED effect. I can change RGB, or I can type in the effect that I want to use. For example, if I want to use rainbow, I type rainbow here with service call /LED/set effect rainbow. Okay, RGB. And now you have rainbow, the default effect that you get from in the start of the drone. You can use just a color. Like if I want to have just a red color, I don't type effect, or I can type flash. And now it is flashing with red. But flash works just 2 times. If you use not flash but blink, it will be continuous. Yeah, continuous and quite slow. So there is also a blink fast. You can read more about a LED strip in the article called LED strip. This is already set, but now you have the list of all parameters that are available. So those are effects: fill, blink, blink fast, fade, wipe, flash, rainbow, rainbow fill. So rainbow fill is what you haven't seen by default. And let's check this one. So rainbow fill is just a rainbow, but it is not rotating, but changing the whole LED strip with certain color, and it goes as a rainbow. But what if you want to access it in your code? So you need to import a service, set LED effect, and you need to have a proxy for that service. Then you have set effect service available in Python. Let's test this in our program, the latest program that we use. The question is, if I want to add rangefinder to keep distance between you and the obstacle facing forward, can the API get the distance from multiple rangefinders? Yes, you can add multiple rangefinders. You will also need to provide a particular frame for each rangefinder, so that they do not face down, all of them. You can have each one facing to each direction. Well, the API, this is not basically the API. This is more of the drones setup, the ROS setup, how you arrange your sensors in your robot. So yes, you can have multiple rangefinders, and this is pretty much, this is not going to be very difficult to get. You will just have multiple rangefinder topics in the topics list, and you can use each data to use in your code. Okay, let's go to this program, the prog2. So what we need to copy you need to copy this line then this line. I will put the proxy to the place where all the proxies are. Set effect. Okay, and now let's have the program to change the color of the LED. So we take off. After we take off, so when we took off, after 3 seconds, we can have set effect. And let's say G equals 255. Let's save that and test. The drone will now take off. Whenever the drone changed its mode to off board, it will go to the purple. It is a default setting. But after it's purple, it should change it again. Now it is green, you see that. So it will stay green until, so it will just stay green forever unless I change it somehow. Okay, let's just stop it for a second. I pressed Control C, so I clicked this in this field and pressed Control C to stop the program. And let's make something more interesting. For example, I want to change the color depending on the height of the object. What can I do? We can basically, instead of printing the rangefinder distance, we can put it in a variable. The variable that stores the data from this callback. We cannot just get the access to this data without any global variables. So let's create a variable distance equals 0.0. All right, and here we will use global distance. And now instead of printing the MSG range, we will say that distance equals to MSG range. Okay, Control S. And now we can access distance anywhere in the program. So let's let's go to fly. I don't need these comments anymore. So we are flying to this place and wait 5 seconds. So now, after waiting for 5 seconds, let's say if distance is less than 1 meter, set effect with R255. Else, set effect green 255. And I will remove this set effect from here. Okay, and now we have our spice 5. Let's do it not 5 but 3 because it's not too much distance from one point to the other. And here and again one more spice lib. And now let's test the program. So the drone is working. Let's run the program. You will now you will not see the data flow because we removed printing from the function. But the drone flies, and we will see whether it's less than a meter or more than a meter by changing in the color of the drone. It should be still green because I didn't change the color from the previous flight, but now as it is going down to wait a second, what is it doing? So it is now red because because the distance was less than 1 meter. Should it land in the end? Yes, it will land on top of this building. And we need to have another test on a somewhere with distance more than 1 meter. So for example, if we're flying on the height of 2 meters, we can use this cube to land on it. The position of this cube is 0.5x and 2.5y. So if we change the position, navigate to 0.5 and 2.5, run our program again, it should turn green and land on this cube. Okay, it turned green because the distance was more than 1 meter. And it is now going to land. So it is landed. And the program is working. It worked successfully. Okay, now you have the understanding of how to access topics from your Python code, and also how to extract data from the callback that is passed to the subscriber. So you can extract this data and use in your code. And I think worth noting that this the data distance is updating very quickly, and whenever you call a new distance, it will be updated. If you want to store distance from a certain period of time, you need to create another variable and say that new variable equals distance, and it will save its distance from a certain period of time. Okay. Do you have any questions on this topic? If you don't have any questions, we may go to the finish.
I think we can wait some questions from you, and after it, we will continue our some organization questions.
Oh yeah, maybe there are some in chat, but can the fixed params file work on other software? What other software you're talking about? Like what? Mission Planner. Now this params file is, well, if you are using PX4, like if you are using PixRacer with PX4 firmware, I don't think there is a difference what software you are working with, as long as it's PX4 and PixRacer flight controller or PixHawk flight controller. But this params file, I don't think you need to use that params elsewhere other than on the simulator. So it's basically the simulator parameters, not really intended to be copied to the real drones. Mm-hmm. By the way, did you try to fix your flip, and did it work now? Those who tried it before and it didn't work. Oh, great. Well, okay, I will answer in more detail to this question. If you have different arc markers in different order, first of all, let's go to this configurational file where you define what arc marker field you're using. So in Clover, it's home Katkin WS SRC Clover arc pose map. And here are several maps that are available for us. You can create your own map. Like we are using right now smith.txt. Now let me open it in Visual Studio. So this is the file that is where you can find the position of each marker, like the size and the position of each marker. The marker with ID 0 has the size of 0.33 and the position of 0 meters, 9 meters, 0 meters, and the rotation 0, 0, 0. Each of the markers has its own position and rotation and size as well. This file helps you generate the drone's perception of what marker field should be in this configuration. And it should be the same in Gazebo or in your physical environment if you're using real drone. If it is not the same, then there is a problem. This the whole pose estimation will be broken. So you are not really going to have a great flight if you have messed map and if these maps do not match. So Gazebo map has the same coordinates that this file has. And also you need to make sure that if you go back, src clover launch, aruco.launch. In this file, you need to provide the correct map name. So here we have smith.txt, the map we are using. If we were to use another map, we need to change this name. There is a built-in generator for the generator of txt files. It's Aruco again. You can find article about that. Let me find that. Marker based map-based navigation. Yes, so fiducial markers, Aruco markers, map-based navigation, and here marker map definition. You can actually run Aruco pose genmap.py and then provide parameters for your Aruco marker map. It will be put into the file that you describe here. And an example of the command is also here. So runner compose genmap.py, and those are the parameters of your microfield. Then this is the file called testmap.txt that will be placed in this home catkin.os src clover compose map and testmap.txt, and you will later need to use that. So don't forget to check the Clover COEX tag for more information. Okay, any other questions? Oh, the question, when should we use JMAF sim? I don't think you will really need this one because it will work with only PX4, not in ROS. So it is not supporting ROS. And no obstacles and so on. The difference between ROSPI sleep for the simulator and real environment. ROSPI sleep works. You may think of it like it works the same on the simulator and in real environment, but in the simulator, if real-time factor is lower than 100%, then ROSPI sleep will wait more because real time of the ROS is slowed down, and ROSPI sleep will also slow down. In real life, it is basically not slowed down. So you don't need to use time sleep. Never use time.sleep neither in real world or in simulator, because time sleep will use your computer's time to wait, but ROSPI sleep will use ROS time, and this is much more precise, and there will be no rush. So if you use time sleep, it will be just not enough time for the drone to take off, for example. Okay, navigate versus navigate wait. Okay, now you can use PyCharm. So navigate wait is actually a function that is useful for navigation, and let me find it. It should be in code snippets, always in code snippets. And so in this function, you just provide all the same parameters as a normal navigate, but it does not require ROSPY sleep after navigate wait. So it waits until arrival without any actions from user. So just use navigate wait, but sometimes it causes some errors because of YAO equals float none. So I recommend you putting YAO equals 0 and frame ID equals Aruka map. So now if you put like, let me just show you navigate wait function in your code. So if you want to use navigate wait, I recommend you put it that way. 0 instead float none, and always frame ID equals Aruka map. And also z equals 1.5 because you want, if you use Aruka map by default, you want to have height of 1.5 by default as well as. So those are three parameters I usually change for in order to make it much easier to use. And now I can, instead of writing this and waiting, I can write navigate wait and 0, 2, and this is it. It will go to the 0x and 2y. And you don't need to put ROSPY sleep. Yeah, this is just how you use navigate wait. Instead of this line, you could use navigate wait as well. It's going to be 0.5 and 2.5 and 2. Okay, navigate wait 0.5, 2.5, and 2. Okay, and this is it. You don't need ROSPY sleep. The drone will fly to this point. Okay, let me just rewrite it, the whole code with navigate wait. Z equals 2, frame ID equals body, auto arm equals true. Then navigate wait to this point and measure distance and land. Okay, let's just run it. So the function is here, def navigate wait, and we use it that way. If I don't, if I use out of order arguments, out of order, like z before x and y, then I need to say z equals to. One more thing, I need to import math because without math it will not work. So import math. All right. Let me see. I press play. And let's fly. It took off. Once it reaches the height of 2 meters, it will fly to the point. I think it's gonna be this point. And then it will measure distance and go down. It should turn green. Yeah, it is green, and it will go down. After 3 seconds. This is it. Okay. Any other questions? Well, I think there is no more questions. So, Svetlana, are you here?
Of course, I am here. It is not a picture on my video.
Okay, so we can finish it for now, I think.
Yeah, perfect. It is great that our participants has many questions. Yeah.
Hey guys, have a nice week. Thank you for attending this lecture. It was
But
fun.
we don't finish for now. Stop exit from the meeting. Okay. If you don't any questions for technical to Timofey, Timofey, please turn off your demonstration screen. Yeah, perfect. So guys, I would like to see you. How are you? How was your hard learning and the deep learning in Gazebo simulation? Hey. Okay, yeah. Yeah, perfect. I see some smiles and I see some tiring views. Okay. Oh, and smiles is I see many smiles, and it is mean it was great and very useful. Okay. So I have some information for you, especially, of course. For now, I share my screen too, and I give you some information about the summary up of our webinar and some next steps which I advise to perform especially for you and in your path of in your educational trajectory. Okay, so let's continue. It will be short. Don't worry. Yes, this is our second day. And as I said before, uh, we we prepared the full ecosystem, which includes industry and educational organization. And now you are a part of this ecosystem, and it's really great for you because it's a big start. It's a great start for educational and for professional and for improve your professional level too. So, as you know, and as I said before, and I believe in it, that open source is the future of technologies, and it's combined many developers around the world, and it help to create a really interesting project, to create really useful product for the market, for the drone market. And our products, our drones based on this platform, and this system help us to start from educational drones and prepare students to the industrial drones, because we use the same electronic parts, flight controller and one board computer campaign. And finally, I would like to provide summarize of our first webinars. Thanks a lot for your hard working. So what we have learned? We know about types of indoor navigation. Also, you know about more autonomous drones. What about their elements, and you will get, and you have got some information about elements which allows provide programming drones. You have learned Python language, Linux system, and you have deep to the Gazebo simulation and provide some introduction on this environment. And of course, some features of working with Gazebo, working with the virtual world, and working with the light strip, and use some information from the sensors, such as a laser rangefinder, and using computer vision system. And don't forget, because this is only the beginning, and now you you located in the blue ocean of this technology, and you can research it and improve it and share with us your process and results, of course. So some words about educational trajectory. So we believe that the one of the main purpose of your education, it's a create project. It is mean that you have any idea, or maybe your friend has any idea, or maybe you want to change the world and create something new. And share this technology for the make open and share this technology for the world. It is really great idea, and it's really great wishes, and you you need some help on it. So to reach this aim, to reach this goal, we see, for example, this trajectory. So practice using simulation environment. This skill help you to understand the basic of the drone flights and how it works in the ideal world, of course. But when you have got initial knowledge about it, you can try a real drone. You can perform a practice on the real drone, because ideal world and real world are different, and you should understand the differences between simulation and real. And when you work with the simulation and real drone, then again simulation and real drone again, you have got knowledge simultaneously. You can update your knowledge, and also you can get fundamental knowledge and improve this level. Uh, these base uh, these base statements will help you to reach the main goal of creating the projects for aero robotics area. Because it's really useful, and you have many opportunities and potential to get it. Yes, and I said before, using real equipment, you will get knowledge about real device, how programming and behavior of the real drone, and of course you can develop your device, your vehicle, which which will um, which will allow us to get more efficient of the time flight or the aerodynamics advantages, and etc. And finally, I would like to tell you about some events where you can participate using your skill in drone assembling, in project activities, and in the drone programming and provide autonomous flights, of course. So one of them, it's World Skills Russia, World Skills Asia competitions, and World Skills competition. Of course, you can start to participate in our aero robotic skills starting from 12 years old. Also in Russia, we have the other competition. It's only open. It is also open for the foreign participants. It will be provided in the summer, and you can participate if you study at a school or university or college. Also, this competition has a focus on only on autonomous drones. And one of the big international competition, which has a popular in the world, in Zirk. This robotic challenge provided every 2 years in the United Arab Emirates. And interesting competition, IMF. In this competition, you can demonstrate your indoor navigation drones, which perform any task. For example, in the previous year, the team should to perform warehouse inventorization using only autonomous drones. They need um, to check goods and create a table of these goods and provide some delivery. So these events, this competition has one similar ability. You have a task from above, from organization, from organizing a committee, and you should perform this task. But also we have another type of the competition. It is copter hack. Copter hack is the competition. This is online contest for projects which you create by self. So what does mean? For example, you have an idea that drone needs to be controlled by robotic hands, and you can perform it. Also, you can equip drone the special payload which will perform any use work. Uh, the, um, the types of the projects can be different. starting from hardware development and finally software development, for example, drone controlled by JESTs or NARAS. It depends only on your fantasy. So some words about Copter Hack. So application deadline for this contest, 31st October in this year. Participation is free without any cost, without any payments. So some words about timeline of this contest. So you can apply up to the end of October. Make application. It will be includes information about your team and information about your idea for this project. After your application, after submitting of your application, you can move to the participant chat and you will get feedback about your project, about your idea. You can discuss with our experts from COEX and other industry companies. And also you can discuss your idea and other ideas from other participants between them. So during to the end of the February, you work on your project starting from idea and goes to the MVP, minimum valuable product. And from 20 to 21st March, it will be final round with demonstration of result of your work, and it will be provided, it will be held in Russia, but we plan to provide two types of formats, online and offline. Of course, if you prefer online, you has equal possibilities to win the main prize of this event. So this information you can find on our website, but I really advise you to use the direct link coex.tech Copter Hack, and you can find all full information about this contest. So, and also the main news which I would like to announce to you, this is Kickstarter. We have launched the campaign of the Kickstarter, and you can support us using this link and get the Clover with open source curriculums and open source image and etc. As you know. So some words about Kickstarter, why it can be interesting for you. So we present the Clover code with regular price in $799, but now you can buy Clover with a discount, more than 30% discount, and the price of the Clover code will be equal $499. Also, we have an offer for Clover bundle. It consists from 2 pieces, and COEX Clover School Kit. It consists of $2,800. So it's really a great discount, and you can check it. So, and also we have one more position in our product line. It is our development flight controller, COEX Peaks, with another with some boards such as PDB, and you can get it on Kickstarter too. Yeah, use this link, and also we share with you this presentation and you can find it. So also I would like to get the feedback from you, because it's really important for us, because we plan to repeat this webinar with different topics of themes, and I think it will be really useful for all of you, and you can leave your feedback using this form. So any questions about, do you have any questions about the Copter Hub, about the Kickstarter maybe, or feedback or another? What do you think? If you have any questions, you can ask it now. Ask in the Zoom chat, of course, and or me personally. So, and finally, yes, we have a big common photo with you. It is really amazing, and also I'm really glad that you have participated in this one, and I hope you have got a really useful experience, and I think you can use getting experience in different events and join us in Copter Hack and support us on Kickstarter, and maybe share with us your events in your country. We will be glad to see how you use this experience for providing events from your site, of course. Okay, so okay, so um, if you don't have any questions, I think we can finish. Okay, so okay, thank you very much for your involvement, and I hope we will see you in the next events. Okay, don't forget to share in your interesting facts or interesting events or etc. It will be really interesting for us, and I think we can say goodbye. So guys, yeah, perfect. Bye bye. Oh yeah, see Bruno. Okay, turn on your cameras, guys, and we can make. Oh, Bruno, you're in dangerous. Yeah. Okay. 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 Really, guys. Thanks for joining us, and I wish you to have an interesting project, great ideas, and wish to learn something new, and create something new, of course. Okay, so see you. Bye bye. Great, perfect. Hey, bye bye, bye bye.